Okay, this is a geometry video over section 4, which is what we're calling Introduction to Proof. I like to call it logic. So the idea of a proof is to basically use evidence and facts to draw conclusions. Okay? I like to think of proof as the why we do things. We answer the question why. Okay? And when we ask the question why, we provide reasons. For our decisions. Okay? So, it's one of those things like, hey, you were late today. Well, why were you late? And if you have a good reason, it's like, okay, fair and reasonable. But if you don't have a good reason, it's like, okay, you're lying to me. What were you doing? All that kind of stuff. So, proof is just kind of a formal way of justifying things and to say why things are why they are. Okay, so this activity we did in class, but let's go ahead and take a look at our lesson objectives before we do anything. First thing we want to do is we want to complete the steps in order to prove algebraic and geometric statements. Okay, we want to also identify proof formats, the parts of a proof, and the assumptions that can be made from a given drawing. Okay. So on this next page, we have all these different properties, okay? The reflexive property means that something is equal to itself, okay? So I want to write these down, that something is equal to itself, okay? Mr. Police is equal to Mr. Police. Mr. Police is not equal to Alan. As much as Alan dreams and hopes to be like me someday, he probably doesn't because I'm weird. But, you know, that's something that he says. Or, never mind. I'm going to edit that one. All right, the next property is the symmetric property, okay? And what that means is that you can switch things around the equal sign. Okay, you can flip them around. Okay, an example of that would be like x is equal to 2. That means 2 is also equal to x. Just switch them around. Okay, the transitive property, switch things around. Okay, just try and stay with me, guys. Transitive property means that if xy is congruent to mn and mn is congruent to ab, then we can conclude that xy is congruent to ab. Okay, so it's like this. If police is friends with Mr. Smith, and then we know that Smith is friends with Mr. Marion, then who am I also friends with? Well, it's not really true. It's not really how it works. But
really friends with Marion?
not well. I mean, they all don't like me very much. But I mean, it is what it is. Okay, we are work acquaintances. All right, but that's the idea. Is that, you know, police is friends with Smith, and I like to assume that any friend of Mr. Smith is a friend of mine. Right? According to me. So if I'm friends with Smith, Smith is friends with Marion, you can conclude that police is friends with Marion if I say any friend of Smith is a friend of mine. Okay? So what that says is that, you know, here if you've got, say something like this, okay? And here's that thing where it says xy is congruent to mn. So if xy is 3, what do we know about mn? If this length is 3, what's this length?
30.
Because they're congruent. Okay? So then, if mn is congruent to ab, so if these two are congruent, if mn is 3, what does ab have to be?
3. 6.
Okay? Then I know that all 3 of these are congruent. Okay? If these are congruent, okay, and these are congruent, then that means that all 3 of them are congruent. Okay, we'll use that quite a bit. The other one is the substitution property. Okay, that's when you replace something. Okay? So, like if I'm gone, do you guys just get to roam free and do whatever you want? You have a substitute, right? Someone takes my place. Someone replaces me for the day. Okay? All right. You will need to know these properties. You will use them quite a bit. All right? All right, so we have 2 things, inductive reasoning and deductive reasoning. Deductive reasoning is, and I'm just going to put this in simple terms, is drawing conclusions based off of facts. So drawing conclusions based off of facts. Okay? And then there's inductive reasoning. Inductive means that you draw conclusions from patterns. Okay? So, a lot of times in the summertime in Colorado, what do we notice happens in the afternoon?
It gets hot. Oh, it rains.
It rains. So, you know, it's one of those things, like if I wanted to walk or ride my bike to work, you know, is that a good idea if I have a computer in my backpack? Probably not, because it could rain. So I end up driving. Yeah. Last week it was nice. All right, so which of these is an example of deductive reasoning? So based off of facts. Okay, Allie notices that a plant grows 2 inches each week. Nikki has a plant, so it must grow 2 inches each week. That's a pattern. That's inductive. That's a pattern. Okay. Bruce asks his friends what kind of music they like best. They all say rock, so everyone in the world likes rock music best.
No.
That's a pattern. Okay, that's not a fact. Yeah. So all even numbers are divisible by 2. The number 18 is even, so it is divisible by 2. Is that a pattern or a fact? Fact. Okay, that is a fact. All right. All right, let's just take a look here. Okay, we got a couple different types of proofs. We have flowchart proofs, we have 2-column proofs, and we have paragraph proofs. I typically do these. 2-column proofs. All right. Proofs involve a few things. It involves given information in words or a diagram, a statement that needs to be proven, an argument using deductive reasoning and justification of steps in a logical order, and then a conclusion. Okay? So I'm going to show you guys how this works. Okay, I'm going to do a proof with you. All right, bear with me. And I do want you guys to write this down because it is very, very important that we understand this, because otherwise you're going to get to the homework and ain't going to be pretty. Just saying. Okay? So when I start a proof, I do a proof like this. I first draw a T-chart. Okay? First step. And a big one. And I'm going to write statements here. And then reasons. Okay? Now the very first thing that you write is the given statement. Okay? So I'm going to write this. I'm going to write 1, and I'm going to write that AB, that segment, is congruent to CD. Okay? Now the reason why I wrote that statement is because it was given to us. Okay? It's part of this given statement. And you know what? These are the gifts that keep on giving. Not the Jelly of the Month Club. That club sucks. Okay? But it's given. And this is my gift to you. Merry Christmas.
What are you talking about? Don't unpause it.
I'm not pausing it because this is important. Okay? I know a statement. I am given a certain amount of information.
That is not a Christmas present.
It is a Christmas present.
Definitely not a Christmas present.
This is all I ever want for Christmas.
That's so
Okay?
very proud.
And the fact that Santa Claus has been debunked by my parents within the last year is really sad and really sick.
Like, you don't even exist when I
Okay?
was 7.
This is the only thing in my life that is ever given to me, and are these given statements. Okay? Alex,
You know what I want?
when you were gone, I gave you a Christmas gift.
It was awful.
It's not awful. It said AB is congruent to CD. All right?
That's the paper's present
Now,
to us, not yours.
what else is another statement that we know? What else is there? Yeah, EF is congruent to CD. Ooh, that's also given. Merry Christmas.
Happy birthday.
Okay? Now, what we want to prove is that AB is equal to EF. Now, here's where this gets a little weird. Okay? Oh, yeah. It's just going to get weirder. Now, here's what I know. If AB, okay, so hold on. Here's what we got. AB is congruent to CD. So I'm going to draw little tick marks there on my little paper. Because not only does it tell me in words, but I can draw pictures to accompany those words. Okay? And then I also know that EF is congruent to CD. So wait, if this has one tick mark on it,
Then you can put outside.
I can put a tick mark on this side.
That also means AB is congruent to
Right. What property is that?
the addition.
Look at your last page.
Symmetric.
No.
No, the transitive. Reflexive.
So here's what we know. So here's the thing. Okay, these.
Symmetric.
No. AB is congruent to CD, right? It's a transitive. EF is also congruent to CD, but we concluded that this has a tick mark, so then this one also has a tick mark. Okay? Save you from the Christmas gifts I'm giving you?
Yes.
Okay. All right, so we know this. AB is congruent to CD. EF is congruent to CD. Therefore, I know that AB is congruent to EF. And the reason I've done this is because of the transitive property.
You forgot a line over top of it.
Yep, thank you. Transitive property. Okay? So now, here's the thing. We have arrived at the proof statement, essentially. Okay? So here, this is what I'm trying to prove.
There's proof
That's a proof.
right there.
That's it.
Number 3 is a proof.
Yeah.
All of it's a proof.
The problem is that they go from this, like, saying a segment is congruent to another segment. They say that the length is equal. Okay? I'm more concerned about you guys just drawing these conclusions, getting down to this part. Okay?
So all of this is proof or is just
That's it.
3 proof?
That your proof is done.
Proof is
Okay? There's a lot of nuances to this. There's a lot of like, jargon that they use and a lot of like steps that they do that are pretty unnecessary in my opinion. Okay? But we'll see how that goes.